In this tutorial, I'm going to teach you how to use a membrane keypad. This is the 4x4 version, but you can also use the 4x3 version. For this tutorial, you'll need an Arduino, a membrane keypad 4x4 or 4x3, and 8 jumper wires male-to-male. This is the membrane keypad, and it works in a different way than a traditional keypad or keyboard with switches. I'm showing you that in a minute. We have 4 rows and 4 columns, and we have exactly 8 lines here leaving the keypad. So what it does is that 4 of these lines are for the columns and 4 are for the back side is actually a sticker which you can pull back. So if you look here underneath, you see that each button has 2 sides which are not connected because there's here a tiny gap in between. When you press a button, the button has on the bottom a little piece of copper which connects these two. So if I'm going to try if I can show you. No, I cannot show you that, but you have to believe me or try it for yourself. But it connects these wires here, and therefore pins are connected here on the output lines. So the nice thing is that in our code we can just detect which button has been pressed, and you have the column and the row line which is connected, and therefore we know exactly the position. I bandaged the keypad, but as you can see underneath there is still the connector. What I did is that I just used the jumper wires inside this connection pin of the keypad, and I've connected these 8 pins to pin 2 to pin 9 on the Arduino. If you can't fill it out by this video, just go to the description of the video and download the course material. All the schematics are there. You can also visit the website. The schematic is there as well. So pretty straightforward for this 4x4 keypad. If you happen to use the 4x3 keypad, then you have 7 connectors. So it's basically the same. You go from 2 to 8 on the Arduino, and in the code we can change it to work with your keypad. Let's have a look at the code. On line 17 we include keypad.h, which is a library. So I'm going to sketch, include library, manage libraries, and we're going to search for keypad. And there are a lot of keypad libraries, so we have to make sure we pick the correct one. And it's this one by Mark Stanley and Alexander Brevik. So please install that library and then we can continue. We have some variables here, rows and cols. If you have 3 columns or 3 rows, then you can change it over here. Make sure you also change this hexa keys variable, because this is 4 and this is 4 lines. So if you change the rows to 3, make sure you only have 3 rows over here, otherwise it doesn't map correctly. So this is a representation of my keypad, which I'm using. Then we're going to define 2 arrays with col pins and the row pins, and the length is the number of columns and rows we have defined on line 19 and line 20. So here we have pin 5, 4, 3 and 2 for the rows, and 9, 8, 7 and 6 for the columns. It can happen that when you press a button and when you run the sketch, it's mirrored or flipped. What basically is the issue is that you mixed the rows and the col pins, or that you have them in the wrong order. When I started this project, and I entered here 2, 3, 4, 5, and basically the keypad was flipped on a certain angle. Like when I pressed the A, I got the asterisk, and when I pressed the 1, I got a D. Didn't work out very well. So I fiddled around with the order, and it turns out that if I use 5, 4, 3, 2 and 9, 8, 7, 6, it's working with the mapping defined over here on line 23. Then we're going to initialize a new instance of keypad, of type keypad, and we store it in the custom keypad variable. What we do is we make a key map of the hexa keys, which is on 23 defined over here. And we also add the row pins, call pins, the rows and the calls. And when we add this to the initializer of this keypad instance, then you basically get by magic the correct keypad mapping and also some interesting functions that I'll show you later. In the setup, we just initialize the serial monitor, and in the loop, we're going to read out the custom keypad, which we made over here, with the getKey function. So we ask the key, which key is pressed, and store it inside the button. Then we have an if statement, so only if a button is pressed, then we show this on the serial monitor. I'm now going to upload the sketch to my Arduino. I'm going to show you how it works. And so I've uploaded my code to my Arduino and I'm now opening the serial monitor. So now I'm going to press some keys on the keypad like 1, 2, 3. They're actually working. 4, 5, 6, 7, 8, 9, 0. Then we have some letters like A, B, C, and D, and 2 symbols, the asterisk and the hash. As you can see, it's working. Like I said before, if they're not correct, fiddle around with the pin numbers and see if you mixed up the calls with the rows. You can use this for your security system, maybe for gaming input. At least it's very easy for you to have 16 buttons in one device. I see you in the next episode.